I'm Jonathan Overpeck. I'm a professor of geosciences and a professor of atmospheric sciences at the University of Arizona in Tucson, Arizona. And I'm very lucky to be here as a guest of the Divecha Center for Climate Change. I feel it's very important for me to understand and discuss scientific issues with Indian scientists. And I also like very much the opportunity to speak with some of the Indian public about the issues of climate change that are so important for people both of the United States and India. Climate change represents one of the biggest threats that Indians or people anywhere else in the world will face in their lives, or in particularly the lives of their children and grandchildren. As the Earth warms, we're going to see large-scale changes in the amount of water that's available, and sea level will be rising, and it'll be harder in many cases to grow the crops we need to feed people, and all sorts of other problems will be occurring. And I like to think of it as a big challenge, but also as a big opportunity, because what do we need to solve this problem? We really need to figure out how to take the carbon out of our economy. Instead of burning fossil fuel that creates the greenhouse gases, that creates climate change, we need to think about reducing our energy consumption, changing the way we create energy to more sustainable ways, such as solar and wind and other technologies. And an interesting opportunity, particularly for India, is that in India now there are many entrepreneurs and many people who know how to take high tech and make money. And I think climate change is going to provide a lot of those opportunities to really fuel the economy for the next 100 years. Well, the study of paleoclimate, or ancient climates, tells us a whole lot about climate system, past, and how it'll behave in the future. And one of the reasons we need a paleoclimate perspective, or one from ancient climates, a geologic perspective, is we want to be able to extend the record from thermometers and rain gauges. A couple things that it tells us. First is that the recent warming of the last 30 years, the Earth is now hotter than it's been in probably over 1,000 years. And the last time the Earth was hotter than this were times like when the dinosaurs were on the planet, times when we know that the warmth was caused by things other than anthropogenic or human activity. Another thing, though, that the paleo or ancient climate record tells us is that when CO2 goes up in the atmosphere, temperature always goes up. When the CO2 goes down, we get a decrease in temperature. So it confirms that what we're seeing now is as CO2 goes up from fossil fuel burning, the temperature should be rising, and that is what the temperature is doing around the whole planet. Another really important thing about paleoclimate is it gives us a lot of climate change in the past that we can test our models. These are climate models that are run on very large computers. They're what we need to simulate into the future. Tell us what the futures have in store for us. More rain or less rain, warmer temperatures, less snow, that kind of thing. And we have to be able to test those models. And the record of ancient climates provides great examples or test beds for our best climate models. And they show us that these climate models are pretty darn good at simulating temperature. So we can trust these models when they say the Earth is going to get warmer. And often we can trust these models when they say it's going to get drier or wetter. And we certainly can trust these models when they say the seas are going to come up and flood our coastlines. And the last thing that the paleoclimate record really is important for me is that it tells us about things the climate system can do, the Earth system can do, that we have never seen in our lives or the lives of our ancestors. For example, there have been times when great quantities of more greenhouse gases have come out of the Earth's permafrost in the Arctic and the ocean sediments. We've never seen that before, but now we have to start worrying that it might happen in the future. It also tells us that the climate can change really abruptly instead of slow and gradually. We may never have seen that before, but from the paleoclimatic record, we know it can happen, and we have to start worrying about, could it happen in the future? One of the other things about the paleoclimatic record is it really highlights the role of CO2 in the climate system. CO2 is the primary greenhouse gas that is causing warming today and climate change today. We know that CO2 today is going up in the atmosphere because of burning of fossil fuel, like coal and oil and diesel. It's something that you know from basic chemistry, but we can also confirm it by looking at the molecules of carbon in the atmosphere and tracing them right back to their source in the fossil fuel. What's interesting, though, in the paleoclimatic record is that CO2 goes up and down. And we have very good records of CO2, say, from ice cores going back thousands of years. And in the natural world, CO2 is like water vapor. They're both greenhouse gases in the atmosphere. And when they go up, the Earth warms. When they go down, the Earth cools. We know that very well from the paleoclimatic record. But the big difference between the past and the future is that in the past, CO2 has gone up only a small amount as climate change warms the Earth a little. Then the CO2 goes up a little more. That warms the Earth a little more. And it's like a big cycle, a positive feedback that warms the Earth. And it's the same exact thing as water vapor. Well, that's quite different from now, because instead of the CO2 going up just a little like it has in the past as a positive feedback in the climate system, now it's going up a lot. And as the Earth warms, we're lucky, much of the CO2 has been taken up by the ocean. Much of the CO2 that we've emitted from greenhouse gas, from fossil fuel burning, goes up into the vegetation. Well, that CO2 is going to come back into the atmosphere at some point and, again, be a positive feedback that will warm the Earth. Right now, I'm standing in a dry stream bed right behind the Divecha Center for Climate Change. And this stream bed is probably full of water as the monsoon comes early in the summer and moves northward across India, and then full again as the monsoon comes back south. One of the things we've been trying to do in studying the paleoclimate record is to see, is that always the case? Does this stream bed fill up every single year? Or could there be times when the stream bed remains dry? And what we're finding in the paleoclimatic record, unfortunately, is there are times when the monsoon just seems to weaken, and weaken for perhaps many, many years, and for reasons that we don't fully understand. So we're trying to make sure that we understand what keeps the monsoon working, and make sure that we don't, by mistake, with global warming, push the climate system across a threshold beyond which we get an abrupt weakening of the monsoon. And all of a sudden, stream beds like these stay dry, not just for a season, but for years. That would be devastating for India, devastating for the world's economy. And one of the things I've learned in my study of the monsoon is that the monsoon can be much more vigorous and strong and wet than it is today. And at other times, it can be weaker, drier. And what I've been trying to do throughout my career, and it's very exciting to be here with Indian scientists, to try and figure out why does the monsoon get so much stronger or so much weaker? And to use climate models to be able to simulate those changes. And in doing so, hopefully, be able to have climate models that we can trust to make good predictions going out even 100 years in how the monsoon is going to change in India, and China, and throughout Southeast Asia, these countries where a huge number of the Earth's population live and rely on the monsoon for moisture. All my career, I've been fascinated by abrupt climate change, and this is a new field trying to look at how the climate system, or parts of the climate system, might change much faster than the climate forcing. So for example, are there ways that as we warm the Earth, instead of having a gradual warming, we might get a much more abrupt warming that could occur in just a few years. That might be possible, but the thing that is worrying me the most are rather than abrupt changes in temperature being caused by global warming, it looks as though it's possible we could get abrupt changes in drought, magnitude and frequency. Where I live in southwestern United States, it's been getting gradually drier, but what we see in the paleoclimatic record is that we could cross a threshold where our climate gets abruptly much drier and droughts become more frequent and they last longer, even hundreds of years, when they occur. And what I'm worried about is that there are many parts of the world that are already somewhat dry. For example, in northern India near Rajasthan, where this could be the case, where people are moving, where people think there's enough water, but instead, in the future, abruptly, there might not be enough water. Another really good example of abrupt climate change is sea level rise. As the Earth is warming, sea level is gradually getting higher. It's starting to come on our shores. And many scientists until recently thought that the sea level rise would be gradual in the future, maybe 30, 40 centimeters of change by the end of the century. What we're learning is that the great ice sheets, Greenland and Antarctica, hold lots of water, and that these ice sheets can lose their mass, lose ice very quickly, and could create a very abrupt sea level rise, where sea level rise would be coming up at 1 meter or 2 per century. And that's really important for India and other countries like the United States, because many people live on the coast. And we're building more cities there, we're building more infrastructure, and our leaders and our decision makers have to understand that we might enter a period where we're going to get an abrupt increase in sea level rise, and that will hurt our investments in coastal infrastructure, and of course they'll hurt the people who live there. So it's very important to consider not just gradual change for the future, but also the possibility that we'll be surprised by abrupt change. And this is important whether you live in India, the United States, or just about anywhere else. A third area of abrupt change that could be very important is the possibility that we might see an abrupt increase in the strength of tropical cyclones, or as we call them back in North America, hurricanes. Everyone sort of agrees now that we're going to get more intense tropical storms. But what happens if that occurs abruptly? And in the past, it looks like that's occurred. Either the storms became more intense abruptly, or their storm tracks changed abruptly, and parts of a coast that might not be seeing very many of the very big storms all of a sudden are seeing many more. And again, that's an area where parts of India, along the Bay of Bengal, could really be up for some surprises. What's the best thing to do about these potential abrupt changes? Well, it's probably reduce the rate of global warming. But even if we can't do that, we have to start thinking ahead for what we might be able to do to make these abrupt changes less devastating, both in terms of our economy and in terms of human lives. Perhaps one of the most famous examples of abrupt climate change, made famous by the movie The Day After Tomorrow, is abrupt shift in the ocean currents, particularly in the North Atlantic Ocean, that today bring lots of heat to the high latitude North Atlantic. And it was believed that those currents could abruptly stop. And they have stopped in the past, but only when we had great ice sheets on the Earth. And now we believe that the ocean currents won't stop, but they'll slow gradually. But the other thing we've learned is that the North Atlantic, far away from India as it is, can still have an effect as it gets warmer or colder on, say, the monsoons here in Asia. So it's very important that we monitor and understand abrupt change everywhere around the world, because often a change far off in another part of the world can have a big effect close to home. In India, there's a great wealth of paleoclimatic research going on that's getting very exciting. Here in southern India, there are people looking at sediment cores from wetlands in the hills that are enabling them to look at how vegetation and climate have changed over thousands of years. Elsewhere in India, they're starting to look at cave formations that also tell you how climate changes, particularly rainfall. In the higher elevation locations of the Himalaya, where scientists are using tree rings to reconstruct both temperature change as well as glacier change and monsoon variation. India also has a wealth of work going on out in the ocean using marine records from sediments at the bottom of the ocean. They can actually look at how the monsoon and ocean conditions have changed around India going back even hundreds of thousands of years. So I would say India has a rich tradition of working with paleoclimatic archives, and the future is really bright for a lot of new work.